Oliver is a pioneer in working in the intersection of AI and human-computer interaction, and he specializes in designing and building AI systems, and specifically to help understand human behavior and responding to them, and using data analysis from sensors. And he has a really fruitful career, and he has designed systems and managed teams at Adobe, at Xerox PARC, INRIA, and also he founded his own company, Stellar.ai. Recent work, so he has a lot of experience working on DARPA from the project. So some notable ones, including the ones that's part of the DARPA Pell program that's commercialized as Siri and Machine.com, and also another one on human personality prediction, part of the DARPA Adams program that's commercialized as part of IBM Watson. And in 2017, Oliver joined Adobe as AI architect, building on the intelligent systems that are used by millions of users. And without further ado, I'm going to pass the mic to Oliver, and he will talk about contextual AI. Yeah, that's big round of applause. Yeah.
Thank you, Paulo, for the introduction. And I'm trying to mic myself back in here. So thanks for having me. And I apologize for my voice, but you know, it's cold season, right? And I flew here from Silicon Valley, and you know, in the plane you get all type of germs, right? And I got, you know, this morning with a little frog in the throat. But yeah, so I want to talk about contextual AI, the next frontier towards human-centric artificial intelligence. So that's something that's very important to Adobe, but it's also based on some of the work I did before I joined Adobe at DARPA, right? So here's a little bit of outlines. I want to motivate what is it actually human-centric AI, contextual AI, what do we mean by that, and why is that important? Then I want to talk about the three waves of AI, contextual AI in particular, and then I want to give a little bit of an overview of what we do in AI at Adobe, and then offer some conclusions. Now, with regard to motivation, and I mean, you guys are studying machine learning AI, right? I certainly have seen this, that there is some criticism that AI today and tomorrow is mostly about curve fitting, not intelligence, right? So we have very powerful tools now that can identify certain classes of objects, separate data, classify data. So it's not real intelligence as we understand it, you know, as human intelligence is, right? That we have a very deep contextual understanding. And this is also reflected by recent investments of DARPA that, you know, we have 2 billion that's actually, you know, end of last year, right? Investment in the next wave of AI technology, right? So what we see right now in deep learning, statistical learning, is very, very powerful, and it's kind of integrating in everyday life in a way, but there's more to come with regard to mimicking or imitating human AI. And this is kind of a nice slide because, you know, it reflects some of the technologies today that we use that have been rolled out that use AI technology, right? Nest thermostat, Google Assistant, face authentication, drones, robots, electric cars. And all these actually are powered by AI. And so, because, you know, they are powered by AI, but only 33% of users believe that they are using AI-enabled technology. That's based on some recent studies that we ran with Pega, okay? So in reality, 77% of users use an AI-powered service or device. So, you know, what does that gap actually tell us? Well, it tells us that, you know, yeah, there's AI that's kind of integrated in more and more devices, but the users are not aware of it, which also means that they are not really interacting with the AI itself, right? It's something that's kind of hidden in some features and so on, right? But moving forward, there is a need for AI to interact more with the users. And we don't want it to be a vision where, you know, AI is in everything and then it's kind of outruling us and being more, you know, more intelligent than us. That's kind of a vision that some of my colleagues kind of advocate and are fearful of, saying, well, eventually it will kill us all. I don't believe in this because, you know, there's several reasons why this is not nice, right? So first of all, we are all humans. We don't want us to be, outruled by AI technology, but then also economically, I believe it does not make sense because AI technology is very powerful, but it has certain strengths and weaknesses that are different and complementary to human intelligence. And if humans in AI can actually interact and form more of a symbiotic system, it's economically much more sound. And where I want to get to here, with this image to convey this is that you really have the human and the AI working together, right? So you are combining human intelligence, where humans are actually good at, with AI technology, machine learning technology, where that is good at. But you do this in a way that you interact between. Both are actually interacting and forming a new symbiotic system. Now, let me step back a little bit and talk about the 3 waves of AI, right? If we wanted to kind of make this happen, where are we right now? What has been happening, and what's the future for AI if we want to have that symbiotic system?
I want to move your mic up higher.
You want to? All right. I'm moving the mic a little higher. Can everybody hear me? Is it okay? Oh, I didn't get any complaints. Yeah, okay. Sounds good. So 3 waves of AI. So if we look at these, so the first, so it's handcrafted knowledge, statistical learning, and contextual adaptation. And contextual adaptation refers to the 3rd wave of AI, contextual AI, that I want to talk about. Now, if we deep dive a little in the different waves, right? Handcrafted knowledge, what does that mean? So that's actually the wave that was around in AI technology in the 1980s to 2000s. So it enables reasoning over narrowly defined problems, and there's no learning capability or poor handling of uncertainty. And I think most of you can't remember this. You're too young, but you had the space missions in the 1980s, and you had expert systems that automated all the processes that had to happen because you could not have a human sitting in the rocket necessarily. Well, there were some passengers in there, but many things had to happen very quickly automatically. So you had to have an expert system that does certain shut-offs and certain automations in that process. And I mean, a famous one that was used there is the CLIPS expert system. And that was something that was based on rules that the engineers actually defined and that were kind of completely defined in advance. Another example is actually the chess computer, right, in the late 1980s, which actually pinnacled in 1996, where you had Deep Blue beating Kasparov. But that was also all based on rules or rule-based systems, right? So you have certain rules that chess is based on, and you use these rules to define what should actually kind of happen. And it was a very constrained kind of problem. So the engineers set the rules that represent knowledge in a well-defined domain. The structure of the knowledge is defined by humans, and the specifics are explored or executed by the machine. And that was in itself already quite successful until around 2004 and 2005, right? Because the handcrafted knowledge kind of hit the limit there. And some of you might know this. You might maybe even learn this in class. I don't know, the DARPA Grand Challenge 2004 and 2005, right? This was actually the kind of starting point of all that boom around self-driving cars. So the challenge was to have an autonomous vehicle to cross the desert. And the prize was, I think, $1 million, right, to do that. And in 2004, right, that was the first year. Well, no team succeeded in doing this. So they handcrafted the rules, how the car should react, and so on, computer vision algorithms and stuff. But there was not enough generality to the model to cover or recognize things that might come up in a random desert somewhere that actually the car had to run through. And then in 2005, 5 teams succeeded the challenge. What changed there was actually that the second wave of AI happened, right? So we moved actually from handcrafted knowledge to statistical learning, right? So here the engineers created statistical models for a specific problem domain and trained them on big data, right? So you have big data of images from deserts and so on. You train on this and you get a model that is much broader, and the engineers don't specify what the rules are, but the data, the structure that is in the data defines that. And the engineers just have the data pipeline and they configure the models that are being trained. And that's the recent success of AI technologies, right? So all the statistical learning, voice recognition, deep face recognition, Jeopardy, right, if you remember that, AlphaGo, all these things are actually powered by statistical learning. So it's nuance classification and prediction capabilities. But the problem there is that there's no contextual capability and minimal reasoning ability, right? So you're training on big data, but big data makes that actually a quite narrow problem. And why does it work so well? Well, you have the manifold hypothesis there, right? So you say that the natural data that you have, let's say you want to recognize certain obstacles in the desert. So you assume that the natural data forms actually structures in a certain dimension, in an embedding space, the manifolds. And each manifold represents a different entity, so it can be different types of obstacles in the desert and so on. And understanding data comes by separating these manifolds, right? So that you can see what is an obstacle and what is not an obstacle. I put a graph on the right side here where you have the different kind of data points that you have, and you separate them by color, right? And you say, well, I just need to have a training and projecting this in a certain dimension that I can cleanly separate this. And why does this work so well also with deep learning? Well, because deep learning, you have all these different layers. So by having the different layers in a deep neural network, while you are stretching the data in new dimensions that enable the enclosed manifolds to be isolated. So you're just adding layers and layers and layers, and each layer stretches and squashes the data space until you can cleanly separate. So you're kind of taking the data, you're squashing it in the different dimensions, you get a classification out, you have a certain error, and then you retrain the whole pipeline and add layers. And what's interesting, that the engineer in the beginning that defined these rules, while the machine learning programmer is now actually designing the network structure, versus before he would define directly the rule for the data. Now he's just defining the pipeline, the network structure with the experience and by trial and error, right? So you're just saying this is kind of the components of the pipeline, and the data will actually run through and define it all. And that makes, I think, the core of the success. And the layering of neural networks provides even further depth, where you say, well, you have, this is an early example also from 2015, right? But that's the kind of a deep learning that classifies an image and gets a caption for an image. So you have a convolutional neural network, first, that defines what the image content is in a way, or image representation, and then you couple this with a language recurrent neural network, and then you get a caption out. And by layering more and more, you can actually get more and more fine-grained classifications. The problem is obviously, yes?
You said a term after convoluted one, but something neural network?
It's recurrent neural network. Yeah, recurrent neural network. So the problem by actually doing this is that you get statistically very impressive results, but they are individually quite unreliable. And I'm sure you have all seen this, right? There's a famous Gibbon example, but you can actually fool these algorithms quite well because it's unclear, what by all these different layers, what is exactly learned? What are the features that the data is training the algorithm on, that you are retraining and retraining? What is actually the thing that is trained? And here, you could just add a little noise, and then a panda becomes a gibbon, even though visually it looks exactly the same, right? So you would not see a difference. And even more interesting, and that's kind of Lab 6 at MIT that did this in 2017, you can actually fool Google's vision engine by saying, well, you start with a picture of rifles, right? And you mix in some noise, and then you train and retrain, or you're not retraining, but you're basically varying the noise that you are adding, and then you get it classified as a harmless helicopter, or a rotorcraft, versus that it's actually guns. And I think I have even a demo video on this, right? There's a little demo video that they had up there, but it's kind of just you're varying the pixels in the picture, right? So you're starting with a dog picture, and then you have a vacation picture, and you mix it in, but in a way that the deep neural network is kind of maintaining the classification of a dog, and you're maximizing for that. But for you, visually, it's not really changing, right? Because you're kind of gradually mixing it in. And what that tells you is that you are not necessarily training on features that are in visually for you perceivable for the human in the image, but you're just kind of training on very big data. Another problem is the bias that you might have in the big data that you train on, and that also is reflected in the model that you actually train, right? So here, this was a problem in Google's Allo messaging app in 2017, that if you put a toy gun, well, a recommendation that you get for next character sub to put in is a man with a turban. Obviously not, if you look at Paul, is there actually a pointer here? Probably not, right? Maybe I can point with my mouse. Okay. Oh, this is even better. Okay, so you see here, right? So you have like a man of a turban if you just put a gun, and it's not an appropriate kind of recommendation to get, but that's what you probably train from the models. Similar here, gender bias. So this is Google Translate. So I'm not speaking Turkish, but I assume that it's a gender-free language for at least certain things. So you can kind of say, she is a doctor, he is a nurse. You translate this into Turkish. It doesn't have a gender in here, right? So you take the same input and you reverse the genders, right? Obviously, he is a doctor and she is a nurse, which it tells you what bias you have in the training data that you actually trained on. Now, to summarize statistical learning, so you see it's very successful but restricted niche applications of AI, right? So you have limited context and adaptation to context. So I have, tried to draw this here a little bit while you have a thermostat or face recognition, face identification. And these are applications that are very powerful, but they are not understanding where you are exactly using that and what other kind of biases might be there. And with the third wave of AI that's coming up right now in different research programs and so on, what you try to get into is contextual adaptation and intelligence. So the systems construct contextual explanatory models for classes of real-world phenomena, right? So meaning you're trying to actually have a representation that is richer and more data around the user to do classification and machine learning, right? I try to depict this here, and I really like this photo. Obviously, this is not a real application that's out there right now, but you have someone who's doing a mechanical task, and you have a robot that's exactly understanding what the current workflow is, where the user is in that workflow, and what's the need of the user. The user here, does not even need to look at the robot, but knows he's putting his hand and knows that the robot is providing the right part that the user currently needs. And that's quite, quite the vision here, to follow. Now, what are the properties of this third wave? And I believe, this is kind of, at Adobe, we believe there's certain properties as a kind of part of requirements that we should have for contextual AI. And I want to kind of call out 4 of them here. So first one, it's very important, is intelligibility. So the AI system must be able to represent to its users what it knows, how it knows it, and what it is doing about it. And that's very important, right? If there's no aspect of the model that is trained that is inspectable by the user, and there are aspects of it that the user can relate to, then that's a problem, right? Because there's very likely to be an error and some debugging to do. And if the user doesn't understand it and you need like a machine learning expert to debug your kind of product, that's not really good, right? Then what you also want is that it's adaptive. So you have to have a certain adaptivity. What that means is if I have a smart home environment and a model that trains my preferences and my behaviors, so if I now visit my mom, well, I want to take my model with me, and it should work in my mom's home like in my home. Meaning, the home has a different configuration, there might be different sensors in there, and there might be certain preferences I have that I don't want my mom to see. And it should also know that, right? It should actually adapt. And this is very challenging, right? It's clear that right now we don't have something like that, but we have to have a certain transferability of the different models. Then the third one is very central, is the customization and control. So if you roll out any AI system that is critical, it has to have, the user has to have the last word in the control, and also the full capability of customization, right? If certain features the user doesn't like, the user must be able to turn them off. And this is obviously important with the first one, because if I don't have intelligibility, if me as a user, I don't understand what the system is doing, I cannot customize it or even override it because I have no clue what the system is doing. So I have to have a certain amount of intelligibility to actually do that. And then the last one, context awareness, it enables all this by saying, well, the machine needs to be able to see, right? The machine needs to be able to have the same pair of eyes as me as a user has. Obviously, it's not the same pair of eyes, right? But if I have a system that is to provide me with services that are based on audio, well, if it doesn't have a microphone, it's not going to work, right? It's kind of obvious, but often we have systems that just don't have enough sensor perception. And this is the human perspective, the challenge, the requirement, the AI perspective, the models and the methods. And I think you guys learn this in class, I'm sure, you know, but intelligibility, this is kind of explainable models. In explainability, that's a big kind of hot topic, I think, in AI right now. How do you make models explainable? Adaptivity is transfer learning, customization and control, user preference modeling, model retraining. And context awareness is sensor fusion, and these are just some of the models that are used there. Now, in terms of technologies, what we also use at Adobe in this case is, I think we want to invest quite a bit in ontologies and taxonomy building. This is kind of, if you have a taxonomy and an ontology, it's kind of something, it's in itself is quite old. It's like 30 years old or older, these like ontologies and taxonomies. They've always been a little dreadful to build all these things, but eventually we'll need it to have a common ground between the users and the AI system, right? So you have kind of to have a model that is, where you have reference point that the user can refer to, and then the machine actually also fills or classifies to. NLP, deep language understanding, and human intent modeling. So what does the user actually really want to do? What does the user really kind of need in the current situation? And then finally, new HCI paradigms. That's a very important one in my current role at Adobe, right, where you say, well, we want to roll out an assistant. And you all know Alexa, right? And it's very cool to interact with voice. But would you do this actually if you are with colleagues in a workspace and you talk to your computer? Maybe, right? But it's disruptive. If your colleague also talks to the computer, there might be interference and it might not really work very well, right? So it's kind of like, well, what's the right paradigm? Maybe voice sometimes, but not always, and gestures might be good. And what are the new HCI paradigms where you mix all these things together? So now, so far so good. Now I want to give you a little bit of a glimpse what we do at Adobe. The AI at Adobe is coined Sensei. Sensei is Japanese for the teacher, right? So the view of Adobe on AI is that it should be something that is helping the user, enhancing the user, and teaching the user and towards the goal that the user has, right? It's something that's not really automating, but really more kind of assisting the user. And the theme is really around what we call creative intelligence. So what does creative intelligence mean? So here it's augmentation of the creator's skills and capabilities. So it means, you have a creator. The creator has certain capabilities, so they should not be automated or replaced, but just enhanced. You want to optimize the workflows, and you want to enable auto-fixing, editing, replacing, auto-styling, auto-curation, right? So you want to kind of give the user a new set of tools and enhance the workflow that the user has. So in practice, what does that mean? So you have deep learning for content understanding. So here, as you might know, you have Adobe Stock. So that's a very, very big image database where we also sell image content. So you can do some image classification. So first of all, as you saw, you detect the faces. That's the classic, right? That's the AI in the box, right? So you kind of, okay, you detect the faces. You tag it, right? So you say, oh, it's beach and family and sea and summer and so on. But then you can go into a space that's more human understandable, right? More contextual by saying, well, I want to detect the emotions in the picture. I want to detect happiness, love, and joy, right? So I want to go into dimensions that are much more relatable by the user. Then what I also want to go into something that's more a human view of this, which is aesthetics. So I want to say, well, how aesthetic is that image? Are there balancing elements? Is there color harmony? Is there content? Depth of field, light? Is there an object? Are there repetitions in the image? And so on. And then I want to even build some type of taxonomical structure where I say, what is actually the category of the image? Right? So is it like, well, broadly you say it's hobbies and leisure, right? But then hobbies and leisure, but within that it's holidays, it's entertainment, maybe a little bit of home and garden, right? Home and garden, I think it's not so fitting, it's only 26%, right? But then you have people, you have family life, couples, women are in there, and feelings is like happiness. And the taxonomical model is interesting here, with certain kind of levels of abstraction because it enables users that come on the Adobe stock web page to search for certain content to very easily find exactly the picture they are looking for, right? Because if I want to look for this picture, and I might not even have an idea that this is the fitting picture for my task, right? But I want something that represents happiness and family life and holidays and so on. And by just specifying this, also in the tree, I can very easily find the appropriate pictures. If I just would say free-form text, I might even have problems to express what I'm looking for. Now, another example here is if I were to look for a more interactive experience, right? So you can the search and so on, I have to specify, but I actually want to directly interact with the search bar. And this one, I have to see whether I can speak fast enough to what it shows. But this prototype here, this is actually rolled out right now, but it's kind of called Hey Sensei. So it's an assistant that helps you to find the stock images and the art that you want to find. So basically what you can do is, you can just say, well, Hey Sensei, I hope you guys see this. So Hey Sensei, and then you just get like some random images, please provide me with a search request. And let's say I want to find some abstract art for my apartment. So it gives you some abstract art that we have in Adobe Stock. But then you want to add some landscape. So it shouldn't be too abstract, so I want some landscape. Then I want to add the ocean as a specific aspect of the landscape. And then, I might want to have a little bit more dramatic elements in there, right? Dramatic, something kind of to get more emotion in it. Right, you see it's kind of interesting, more red color, the dramatic. I don't know why, but that's how it identified that. So you want it even more dramatic. Now, for my apartment colors, I want also more red in it, so I can actually say more red. Right, and then what you get is actually, my favorite is this one. This is the one I chose here in this search. But I think you get an idea, right? Because you can use concepts that are human relatable in this and have an interactive experience while you search, and also use all the AI models under the hood. You can actually stack them together using AI. So what we also do is neural stylization. So that is a little bit of a box application of AI still, but you see this here where I can start with a picture of my house. And then I have two historic artworks, right? And I say, well, I want to actually combine those two to create a unique painting of my house. And given the structure that is in the artworks and in my house, it's kind of perfectly blended together, right? You see like different elements from the different paintings I actually put into this, and then I get like a unique representation of my house. Another one is the deep cutout. So this is actually kind of interesting work because it enables, if you think of like some flagship products like Photoshop, right? A very important task in Photoshop is to cut out objects because you have pictures and then you have a tourist in your vacation picture and you want to remove the tourist and stuff like this. So how can you get a deep cutout of objects that have actually meaning for humans? And it's not necessarily just by specific features and shades and so on, but also by the meaning of a certain kind of area in the picture. You see like a cat on top of the computer, right? So the cat might actually even have the same color as the computer, but just by it being a cat, you can kind of cleanly separate it. People from the background, cars and so on. So it's kind of quite interesting work, and you get 92 to 96% accuracy what people would perceive as a salient object in the foreground with this, and it's, you know, it runs pretty fast. It's a half second to identify this. And this is used in the next demo I'm going to show, because this one is also, I think, with audio. Let's see. So I don't have to talk to this one, hopefully.
Using your smartphone to create a great portrait photograph isn't so easy. What if we can tap into the power of artificial intelligence and machine learning to transform bad portraits into good ones? Let's take a typical selfie and transform it so it's more flattering. Here I'll make it appear as if the picture was captured from a distance more typical of a traditional portrait shot. You can apply automatic portrait masking to instantly give your image a pleasing depth of field effect. See a style you like? Simply select it. And in one click, you can edit it like a pro. This is just a peek into the future potential of mobile portrait photography, powered by Adobe Sensei.
So I think you get the idea, right? So really the interesting part here is obviously the individual capabilities of the software to enhance your face, but also to orchestrate all this together so you can really edit your portrait photograph to be the way you want it, and to be also able to identify the right features, you know, that you need, and to get to them and to be able to use them. And that's also in my current kind of role and job the challenge, right? How do we get the right features to the right people that need them, and how can we quickly orchestrate all of this to get like the best image quality or image editing for people? Now some conclusions. So as I kind of said, AI needs to evolve in the third wave to respond to the human challenges of intelligibility, adaptivity, customization and control, and context awareness. And with creative AI, what we do at Adobe, we are kind of working towards that in the examples that I showed. And the enabling technologies that we also build out right now and also hire personnel in, I have to say, is obviously the core one that's enabling most of the things that are going on right now is deep learning. So we have Adobe Stock, we have a lot of behavioral data, so we have large-scale infrastructures that we have built and we are building. We have the Sensei platform that is rolled out, which is our kind of core machine learning platform. But then on top of that, you know, we need representation of knowledge, ontologies and taxonomies, right? So what is creative intent? What is the creativity that people actually want to do with Adobe software, right? So we need to build out these models, and we have to have the people that actually build these models. Then NLP, so here, you know, I think a key thing is deep language understanding and human intent modeling in this, right? So how, I mean, you saw, you know, this interactive interfaces where you say, well, give me this and that, and you could also use voice for this, but well, how can I really deeply understand what you want? Even you know, if you're a beginner, you might not even know how to express certain things. How can we translate this to the feature that the user needs? And then new UX and UI paradigms, right? So I mentioned voice, gestures. I mean, what is very central for us right now is also augmented reality and virtual reality. So that's something we invest quite a bit. So, I can say, well, how can I enhance the experiences that people have, and also the interaction to kind of put things, you can have an interaction even with an object that is virtual and that you see on your phone, and you can interact with it, right? Things like this, we are currently actually exploring quite a bit. And there are products that are coming out for us on the Experience Cloud side, which enable people to edit these experiences. So that's all I wanted to actually share. I don't know whether we have time for Q&A. Also, I shall also point out that, there was in the invite actually a link that went out also to connect with Adobe, right? Because we are always interested in great talent, which I think Georgia Tech has. So if you guys want to get in touch with me, obviously you should reach out to me directly, but also, through the website you can get a lot of interesting information about Adobe and roles and stuff that's there.
We can do some Q&A.
Yeah, good. So are there any questions, comments, anything? Yeah, about this, but also about Adobe in general, right? So if you want to know more about Adobe, I'm happy to talk about anything. Yes?
I'm curious which of your software is using the neural stylization you showed us. Is that a Photoshop app? And do you envision partnering with Alexa and Google?
Yeah, so we have, it's Photoshop. So this is something that is actually rolled out in Photoshop. So there are certain plugins that have that in Photoshop. We are not partnering for the core apps like Photoshop or Illustrator. We are not partnering with Alexa or any of that, just because we don't think that pure voice input is the right modality, but we have collaborations or cooperations with Alexa in the Experience Cloud. And I'm not sure how familiar you're with that, but most people think of Adobe, what are you thinking of PDF and Photoshop, right? And the company has three main kind of pillars, right? So one is documents, so that's PDF, and it's very old, but it's a very profitable business still, right? Because PDF is used for also things like signing, business processes and stuff like this. Then you have the Creative Cloud. So the Creative Cloud is all Illustrator, Photoshop, Spark, all the different things to actually create things and create content. But then you have the Experience Cloud, and the Experience Cloud is to design user-facing experiences and web experiences. So this is things like, if you, I think Coca-Cola is here in Atlanta, right? So if you look at the website of Coca-Cola, right, and the user experience that you see there, who do you think powers the analytics and the experience itself? Well, it's Adobe software. Okay, so the design of how the flow is and how all these things work together, that's actually Adobe. It's XD, it's Experience Manager, right? So because you have the actual creativity and the elements, but then the whole experience is powered by Adobe. And we do this for big corporations like Coca-Cola, General Motors, and so on. But right now, recently, we are also moving more towards also the small and medium enterprises with acquisitions last year, Marketo and Magento, which were companies that were in that space. They are now part of Adobe. I hope that answered your question. Any more questions?
I have a question.
Yes.
So, and you will need to repeat it because otherwise.
That's right. Yeah.
So, a lot of students always wonder about data science positions, working in companies, for example, Adobe.
Mm-hmm.
What would be companies looking for these days, for data analysis, data analysts, data scientists?
Mm-hmm. So Polo was saying whether what are the data scientist positions that Adobe is actually looking for, and companies in general these days. So what we have in Adobe, we have a lot of data, because everything that you do in apps is logged. Right? So there are certain entries that are going into our clouds. And we have a whole arm that is analytics. So what I said with the Experience Cloud, so because you have the user experience that is rolled out, like let's say Coca-Cola website, but then everything that happens with users in that cloud, in that website, all the analytics is basically provided by Adobe, which is enormous amounts of data scientists that crunching this data and building this data and these models and what kind of, how can you predict churn and so on. So this is something that is obviously also owned by the actual companies that have that, like Coca-Cola, but they use the analytics product that we provide. So we have to do a lot of these things as a service that we provide, right? As a tool, as a software that we sell to these companies.
I have another question.
Another question.
So,
you have a lot of questions
yeah,
today, Paula.
So this class is data and visual analytics.
Yeah.
So visualization, I think, is new to a lot of students. So this is probably the first time they work with visualization and then get to know its usefulness. So internally at Adobe, for example, like when you're doing AI, how is visualization used like internally, maybe help inform how they make AI and evaluate? Can you talk about the role of visualization?
Yeah, that's a very good question. So visualization is very central also because, there are several aspects to it, right? So you have people that are very data-driven, and I assume you guys are very data-driven, doing also machine learning and so on. But Adobe is a company that does a lot of, it's in its core a design and marketing company, which means that many of the people that are actually the users and the consumers of the data or the outcomes of the data are actually visual people. Visual meaning, they want to see a graph, they want to actually get a look and feel of the data. So if I come with a data sheet and a spreadsheet, that's not going to convince them, right? So the designers and so on, they want to have very crisp and convincing visuals to understand what the data is. And I think that's also something that I learned around data visualizations, that if you are a data scientist, don't assume that those who are the consumers of your analysis and so on are as nerdy as you, okay? Because often you have to sell your results to people that are, executives, they have no clue, right? And they want to actually see visuals, and you have to have the tools to present the data in the best way, right? So you have to have like the right kind of things to make to draw and spin a convincing story for someone who only has a minute to look at your stuff. And if you come with like a spreadsheet and all type of numbers, they say, I don't want to even look at that. It's just too overwhelming. Right? Yes. Oh, yeah. Yes.
In this class, you've been discussing lots of tools that are used for data analysis, whether it's Hadoop, Spark, different kind of back-end tools. I was wondering, are a lot of the tools you guys work with at Adobe in-house tools, or sort of just kind of if you could speak along those lines?
Yeah. Yeah. So the question was what type of data science tools and visualization tools we actually use in Adobe. So Adobe uses quite the normal tech stack. So we use Spark, Hadoop, and also Tableau and all these type of visualization tools. So we have, I think, quite standard things that we are building customized tools for our customers. So there's kind of in the analytics space, as I said, right, there are certain tools that we build, but internally we are using the normal data visualization tools. I don't know where the other question was. Well, same question, perfect, yeah.
You talked a little bit about the first wave of AI with more handcrafted knowledge and rule-based systems as opposed to statistical learning.
Yeah.
Do you find that any of that more traditional handcrafted knowledge AI techniques are relevant in Adobe and I guess the industry at large, or have they mostly been pushed away for statistical learning?
This is a very good question because for the expert, the question was, we had the first wave and the second wave of AI, and whether the tools of the first wave of AI, like expert systems, are still widely used, or there are certain areas where they are used. And I think there are some statistics that still for the AI-powered systems nowadays, even most of them are expert systems. So if you think many of the things that you actually see deployed, they are not like deep learning systems, but they are just kind of powered by simple rules and rule reasoning and so on. So there are more systems out there still that are powered by this than you actually might think. And we internally, I mean, all the stuff, we are lucky because we have many like image data. So when it comes to sensorial data, like audio data, image data, deep learning is very, very powerful, right? You can, because you have also a lot of data to train on. So many of the things I showed are actually deep learning models. But still, for some of the decision making, we have the expert systems and expert system models.
How did Adobe come up with the name of Sensei?
So how did Adobe come up with the name Sensei? That is a very good question. That was actually before my time at Adobe. So, but I think they have a very good, that's why, the DNA is a little bit also of a marketing company. So they internally said, well, we have to coin our AI and get a unique spin to it. And then the designers and the marketing department and the machine learners came up with the notion. That's kind of the story that I know. Yes?
You spoke about contextual AI and that this is the new wave of AI, but doesn't that limit the use of AI technology? Because, for example, I'm not American, and when I take most of the American-produced products back home, most of them don't work because they don't understand the context of the environment,
Right.
of my home country's environment. So doesn't context AI almost limit the usage of AI because it becomes very specific to particular contexts, and contexts are not the same across the world?
Well, that is a very good question. So the question was whether contextual AI doesn't limit the use of AI when you go to a different environment, like a different area of the world or something like this. And I think in the definition, of contextual AI, it should actually empower that. So, if you think of the aspect of adaptivity, so if you say, well, you want to contextualize AI, it's true if you incorporate more and more kind of specific aspects of the context. If you say you have like just AI in the box, I can easily transport this, right? So if I have more contextual data that are actually incorporated, it might limit the use, maybe in the beginning, but by having also the ability of adaptivity, because you train it to work in your home and your mom's home and so on, so it should also have the capability to be adaptive enough to work in a different continent and with different people. So ultimately, that's kind of the goal of it. It's a hard problem, so we are not there yet. But I believe that from the vision, that's what's intended. Mm-hmm. Yes.
So speaking of the data set, I'm thinking about the image you showed to us about a family on the beach. So are you using that kind of data set to train real models? Because that contains a lot of attributes or properties that would be really hard to mark.
Mm-hmm.
And among those properties or attributes of this kind of images, there are a lot of emotional, semantic properties that you introduce. And I think they could be kind of hard to be labeled, to be tagged,
Yeah.
because they are very subjective.
Yeah.
Like you said, I saw that that image, like happiness is like 96.86%, something like that. So how can you say that is the accurate number for that kind of image? Like there's no standard for that.
Yeah.
So how could you manage to make a data set like that?
Yeah, so this is a very good question. So the question was, how do you get to classify all these images also? How do you get the classification information for the images? And if you say it's like 65% of happiness or something, right? How do you come up with these numbers? How do you actually get the image data even labeled? So it's a very good kind of question. So what we spend a lot of money, a lot of time in doing the image labeling. So if you think about like this, the image with the beach, right? So there have been at least 5, 6 or more people labeling this image with different labels and different judgments of what amount of happiness might there be in the image, or if any, right? So we use different, like also third-party services to get this image labeling done, because it's subjective. It's clearly subjective, but the only way you can get even some type of number is by saying, well, if you have so much subjectivity, well, you are adding up a lot of subjective judgments and say, well, maybe if I add it up and I factor it out, at some point I get something that's commonly acceptable. There's still a bias in it, right? So we have still the bias, and a certain bias that we train. That's the problem with the current wave of AI, that it's still a little part of. But by getting a lot of the data and a lot of these labels, we think we get a good kind of gist of what the images represent. One last, yes, please. Can you speak a little louder? I can't hear you. So you mean because they released this and they didn't open source it, whether it's kind of a proprietary thing? That's what you mean?
No, it was too good. It had like indexed 5 million news articles, and it could write like a professional editor. So
right.
Everyone becoming a professional, having that access.
Right, having that access. Well, I think there's still a lot of work to be done on this. I'm not sure I completely, did you acoustically understand?
Some of it, yeah. So I think, are we ready for the AI, third wave of AI?
Basically, whether we are ready for the third wave of AI. Well, I think it's ultimately the only chance we have, right, to make AI like a success in everyday life. If you say you want to have it really in the workflows and everything that we do every day, we have to have a way to integrate it.
I think to build on this question, do you actively label things as AI produced? Like if I were to read an article that says this is by such and such AI.
We actually do.
Okay.
We actually do. So you might have noticed, we don't say AI, we say powered by Sensei. And I mean, Sensei is kind of the Adobe AI, right? But we do.
So Sensei creates images and you put like an icon on them or something? Or?
Well, so we don't do we have research in it, but we don't do GANs and stuff like this where we kind of say, well, we are dreaming up images. So right now we don't do that. It's more like because our user base is a little bit more conservative. If you take designers and so on, they don't want to be replaced by us auto-generating the...
The house you showed us was auto-generated, right? The art.
Yes, but that's actually a good point. So the house that I showed was auto-generated, that combination. But the choice of the images was the user. So you can say, well, you could have done it by yourself, kind of, right? But you're using that, but you're not saying, well, I just want some kind of artwork, and then it's making up something that's not even real. So because our user base and the designers are very skeptical of that. Cool.
Yes?
Yeah.
Thank you.
Yeah, thank you.